Okay, guys, let's now look at cotangent graphs. And again, that's y equals a, the cotangent of bx. And remember, the cotangent of x equals the cosine of x over the sine of x. So remember, if we did say the cosine of 0 over the sine of 0, well, what's the cosine at 0 if we start on our unit circle? Well, that's at 1, right, because that's x. And then sine is y. Well, what's the y value at 0? That's 0. So again, there's this undefined quality, and that's where we have these vertical asymptotes. And they're going to be at multiples of pi over b, the absolute value of b. And remember, that's also our period. Our period is pi over the absolute value of b here. Okay, so y equals a cotangent of b of x. And remember, a is our amplitude, but we don't have an amplitude in the traditional sense. But we are going to want to use that a value because that's where it's going to go through on our intermediate location. So it's still valuable, but we don't have an amplitude in the traditional sense like we would in the sine and the cosine graphs, right, of the waveform graphs. And then remember, b here corresponded to our horizontal stretch or shrink. A is vertical stretch or shrink. Okay, so we want to start with these few ideas, and then let's get into graphing one of these functions and go through the process. So, and again, notice that at 0 here is where our asymptotes are. So these cotangent graphs won't have that offset quality that we had with tangent graphs, and we'll see that in just a minute here. Okay, guys, let's look at a particular graph here. G of x equals cotangent of 1/2 x. And let's graph this. It's got a transformation in there. And, of course, we always want to start and identify our a coefficient here. And, again, it's amplitude, but it's not amplitude in the traditional sense. So the absolute value of a is absolute value of 1, which is 1. And then, of course, we want to look here for our b. And remember, our period is pi over the absolute value of b. And in this case, b is 1/2. Well, the absolute value of 1/2 is 1/2, and then we invert and multiply, so that would be 2 pi. Okay, so our period length here is 2 pi. Let's go ahead and start with graphing. Okay. So, again, remember how we talked about how for cotangent, which is cosine over sine, then at 0 is where we ended up having that vertical asymptote. So I essentially have a vertical asymptote at the y-axis here. And, of course, I'm going to have an asymptote at the end of my period, okay? So these are going to be defined just like our tangent graphs by these asymptotes. And our period is, well, if we started at 0 and we have a period length of 2 pi, then it should be here at 2 pi. Okay, and then, as with all of these, if we want to, the easiest way to find those intermediate locations is to take 2 pi, whatever our period length is, and divide it in how many pieces? You got it, 4. Okay, 2 pi divided by 4 is pi over 2. Okay, pi halves. So let's divide it into 4 equal sections. All right, and remember, we're going to add whatever that amount is to our starting location, pi halves. So I'm here at pi halves. And then, of course, I'm going to add pi halves again to that. Pi halves plus pi halves is pi. Plus another pi halves is, again, 3 pi halves. So we're, again, adding this much each time, right? Whatever our period length is divided in 4. Okay. Then, now our cotangent graphs are going to go the other way. And I'll evaluate a couple points here in a minute just to confirm. But when I do that, what we find is that at these intermediate locations here of pi halves and 3 pi halves, well, it's whatever that amplitude is amount. So 1, 2, 3, -1, -2, -3. So at pi halves, I'm going to be here at 1. Pi, I'll be at 0. And 3 pi halves, I'll be at whatever that amplitude is in the negative. And then I'm going to go ahead and draw my shape. So I'm just going to go ahead and do it this way, and we'll, of course, evaluate a point. We could always evaluate the points whenever we're not sure, whenever there's any doubt. Okay, so notice our cotangent graph kind of has the opposite behavior of the tangent in the sense that it starts top left and goes to bottom right, whereas the tangent graph is bottom left up to top right, right? Okay, and remember, it doesn't have that offset quality around the y-axis here. It just starts with the asymptote at the y-axis, and then whatever your period length is. Okay, and let's say we wanted to, say, do another period's worth. What would I do? Well, my period here is 2 pi. I could just add what? 2 pi to whatever my ending location is. Okay, and that was our original function. Okay, so our period is 2 pi. Let's add that to 2 pi here, 2 pi. And let's divide it in 4 equal sections. So I'd be 2 pi plus 2 pi. Then is here at 4 pi. Okay, and then how much did we add each time? Well, 2 pi divided by 4, pi over 2. And I'm going to add that pi over 2 each time. 2 pi plus pi over 2 times 2 over 2. That'd be 4 pi halves plus pi halves. And that's 5 pi halves, and so on. And I could keep going, adding how much pi halves each time. Okay, so let's just evaluate a function to show that we could. But it's, again, going to take the same shape. And at our intermediate locations, it should be at whatever the amplitude value is if it hasn't been transformed in some other way, shape, or form. Okay, so let's evaluate this 5 pi halves. The cotangent of 1/2 times 5 pi halves. Well, that would be the cotangent of 5 pi fourths. Well, 5 pi fourths on the unit circle, I go, well, if I were to draw it, 1 pi fourth, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. Okay, and remember this was my initial side I started with there, the x-axis, right? So this 5 pi fourths is really a 45 here in the third quadrant. So again, you can use the root 2 over 2 for each side if you want to put it on the unit circle, or you can go back to the 1, 1, root 2 thing and construct it from there. Okay, so tangent here, but remember, this is positive 1 comma negative 1 there, right? Okay, so that would be 1 over, well, it would be negative 1, right? So cotangent, again, is cosine 1 cotangent of 5 pi fourths, which is the same as the cotangent of this 45 in this third quadrant, is going to be cosine, which is x, over sine, negative 1, negative 1. Okay, so that would be negative 1. Oh, excuse me, this is negative 1 here too. Negative 1 on x, negative 1 on y. Got to be careful there. So negative 1 over negative 1, positive 1. And I was thinking, wait, what? That's wrong. It should be up here. So always check your work against what you know. And then, of course, this one should be a negative 1. And I could, of course, find those by just adding whatever that pi halves to each one. And then I could evaluate them using, say, the unit circle, okay? Okay, so there's 2 periods worth of a cotangent graph, and notice it has a similar behavior as tangent, but it's flipped, and then it doesn't have that offset quality that a tangent did around the y-axis to begin. Okay, so I hope this helps you get started on the cotangent graphs in 9.5. Thank you.